This is a molecular model of a disubstituted cyclohexane, and in fact it is 1,2-dimethyl cyclohexane. Here's one methyl group here in an equatorial position. Here's another methyl group right next door, and it's pointing straight up from the ring, so that makes it axial. And you can also make out that this would be the cis isomer. And what we try to do when we draw chair conformations on paper is represent this model as best we can, even when we're looking at something that's two-dimensional. And that's what this piece of paper is all about. This is one of the documents you have access to in Chapter 3, and it shows for plain old cyclohexane the two versions of its chair conformations, one flipped relative to the other. The idea being that bonds that are axial in one chair become equatorial once you've done that flipping. So it's a lot easier to see what that flipping is all about if you actually have a model here to manipulate. So if I grab this ring by two carbons that are on opposite sides, and one carbon is going to be slightly above the other one, they're not all in the same plane. And if I take the one that's kind of up and push it down, and at the same time take the one that was down and push it up, I can accomplish this ring flipping here. And so if I now spin this around a little bit, you can see what we've got here are green bonds that are axial and the pink bonds are equatorial. And if I go back to where I started, if you had noticed, the ring started off with the pink bonds being axial and the green ones being equatorial. And I can flip this back and forth and go between those two versions of that chair conformation. So when this thing flips, all the bond angles change. And specifically, axial becomes equatorial. So here we are again with pink axial bonds, and it doesn't matter which two carbons I grab as long as they're on opposite sides of the ring. It's very easy to manipulate this and make it do that little flipping. And notice that the two methyl groups, no matter which version I have, one is going to be axial and the other equatorial. I can just choose which is which by which conformation I choose to leave this in. But we are, again, trying to represent that idea on paper often, and so it requires a little bit of artwork. But this is a very good template here for allowing you to draw reasonable looking chairs, and also to show clearly which bonds are up, which ones are down, which ones are equatorial, and which ones are axial.